All right, ladies and gentlemen, welcome back. So here was the problem that you were supposed to do on your own. So let's go ahead and do it together. This is vertex form, which is y equals a times x minus h plus k. X minus h squared, I should say. So identify my a, h, and k. My a value is 1/2. My h value is positive 3. Remember, plugging this into the formula makes x minus 3, and that's what that is. It's not negative 3. The h value is positive 3. And my k value is negative 4. So my vertex is at 3, negative 4. So I can go plot that point. 3, negative 4. Now I use my a value of 1/2 to find another point. So I'm going to go right 1, up 1/2. And then I can do the same thing on the other side because it's symmetric. And then it's going to go something like this. And again, if I wanted to make this more accurate, I could place the y-intercept down. I can find that by plugging in 0 and those types of things. But this gets me a general view of what the quadratic looks like. And all right, if you have any questions about that, make sure you address them. Otherwise, let's go ahead and move on to our next example where we look at intercept form. Now, intercept form is the last of the forms that we'll look at when it comes to quadratics. And notice the difference in how this is formed. This is created by multiplying two binomials, right? Two-term expressions. Okay, so this one again has some special features. So these values, the p and the q, are the x-intercepts of the quadratic. So if I were to say I've got a equation kind of like this here, right? This might be an example of how this looks. Okay, these two values, p and q, are my two x-intercepts, right? This would be like p equals negative 4 and q equals 2. Okay, so these two values, the ones that we're multiplying here, are the x-intercepts. Notice negatives in the formulas. Okay, that's important. Then we've got the axis of symmetry. Notice that that's p plus q divided by 2. That is halfway in between the two values. So like I would add these together and I would get negative 4 plus negative 2 divided by 2 is negative 1, which means right here at negative 1 I've got my axis of symmetry. And my vertex is on that axis of symmetry. So if I know what my x-intercepts are, I can find the axis of symmetry in the middle, and that tells me where my vertex is. Finally, that a value in the front, if it's positive, it means the graph's going to open up. If it's negative, then it's going to open down. Okay, so let's go ahead and put this all together to do an example. So here we have y equals 2 times x plus 3, which we're going to write this as x minus p, and times x minus 1, which is x minus q. So find the x-intercepts. In other words, identify p and q. And in this case, the p and the q values, notice again, negative in the formula means that the p value is negative 3. When there's a negative in the formula, it reverses that number, like with the vertex form. And q, which is positive 1. So these are my x-intercepts, and I can go ahead and plot them. Negative 3, positive 1. Now I know that this is going to curve somewhere in here, I just don't know where. So we're going to find the vertex, and the way that we find the vertex is by using that p plus q over 2. That's going to find my x value. So that's negative 3 plus 1 divided by 2, which is negative 2 over 2, which is negative 1. So I have a axis of symmetry here at negative 1. But I need to find out where along this axis of symmetry is my vertex. So we take this value and we plug it into the function. So I'm going to take that y equals 2 times x plus 3 times x minus 1. Oops. And I'm going to replace the x with -1. So that's -1 plus 3 times -1 minus 1. This is then 2 times 2 times -2, which is -8, I believe. So it's down here. Oh, my graph isn't quite big enough. It's down here. I'm going to go down as far as I can. That should be -8. So there's my vertex, -1, -8. And I know that then, since I know where my vertex is and I know where the x-intercepts are, I can then draw my curved line for the graph. Whoop. Oh, that got messed up. There we go. All right, and that's it. That is intercept form. The main thing being find the intercepts. That's why they call it intercept form. Use that to give us where the axis of symmetry is, and then we plot the vertex. Connect them all together in a line. All right, so there's one more example of trying something in intercept form back on your canvas and on your notes. So go ahead and do that. We'll see you in a couple minutes to check your answers.